So now in this video, we're going to just do basically multimeter voltage measurements again. This time though, I want to look at how much the N Channel Enhancement Mode transistor, I'm using a 2N7000 right here, what the voltage range is for turning it on and off. So there's a general principle, a low input, so close to ground there, it's going to be off, and a high input, close to the power supply, it's going to be on. But of course there's going to be a middle ground region, and it looks like about halfway is when the LED starts getting dimmer, but that's at 5 volts. So I'm assuming that it's somewhere about 2.5 volts. I confirmed this earlier, but I'm going to make a video on it. So I'm going to kind of act like I haven't confirmed it yet. So that's a 1000 ohm resistor, so I can go up to 12 volts. Yeah, there you can see power supply is set to 5 volts. Since we're using a 1000 ohm resistor, when the LED is on fully at this voltage, we're only going to get about maybe 3 milliamps of current. But in any case, this is the voltage across the LED and the resistor there, the load. So black probe, I got this alligator clip, and there's a jumper that I attached, this jumper wire there, and so that's at the cathode, short lead of the LED. And then we got this one, that's to the positive supply, which is also the end of the resistor there. Across the resistor and the LED is the voltage we are measuring. So when the transistor is conducting fully, it makes a almost direct connection to ground right there. And so we're getting, pretty much the full supply voltage. We lose a trickle across the load. But there you can see now it's starting to go down slightly, but at some point it's going to go, there we go, somewhere about halfway that I set the trim pot. So somewhere about 2.5 volts. There you can see it's really rapidly dropping, even though I'm just moving slightly. Whereas up at about this point, all this area, we're practically got the transistor fully on right there. So, and I'll zoom in. The transistor again that we're using is an N Channel Enhancement MOSFET. I'm using the 2N7000, flat sides to the right. We got the source to ground there. We got the gate there, that's the control. We don't need to limit current. We can give it either supply rail voltage. The gate doesn't let current in or out, so that's the white jumper. And then at the top where the blue jumper is, and the cathode of the LED, we have the drain up there. So source, gate, drain, and so we're measuring across the LED and resistor load. Now let's bump up the supply voltage to 12 volts and see the result that we get. So I didn't measure it, but yeah, it was like 2.5 volts, the halfway point, when the LED, if I went lower than that, the transistor would start turning off, pretty rapidly. Now we got 12 volts. And there you can see we got 12 volts across the load there. Of course I can go up. Now it's not the halfway point anymore. I gotta go way down, and so it's dropping a little bit now. There we go. Right about this point here, there's a huge change in how much current it will let through. So let's go up till right. Yeah, 11.8. And yeah, right about this point. I'm gonna just kind of tick it up. There we go. 11.7. I'm going to guess at the gate there, in relationship to ground, we got to do that, will be about 2.5 volts right there. And there you can see it's like 2.4. So my estimate was right. Whatever the supply voltage is, you need the gate about 2.5 volts approximately, higher than ground, which is also the source right there, before the transistor will be on fully. And with bipolar junction transistors, when the transistor is not conducting fully, but it's conducting a bit, that's called the active region. So I don't know if those terms apply to MOSFETs or not. But yeah, there you can see we can control how much current flows through by adjusting the base voltage in this case. And that's compared to the source right there. So some circuits you'll see the source is not to ground. There's the complementary push-pull transistor combination where you have a PNP, bipolar junction transistor, down here, and that's where ground is, on the other side of the PNP. So where they connect together is, you know, kind of a halfway point between the supply voltages. What matters is this voltage difference between the gate and the source right there, not the total voltage of the circuit. But in this case, this source is to ground, so it makes sense in this case. 2.5 volts above ground is when the transistor is conducting fully. This particular one right here. So this is just a test that I just came up with today to do this. I may have done it before, you know. That happens to me a lot. I think to test something out, and then I find out later on I made a video where I covered that. But I didn't remember, you know, the results, or that I had even done the test before. So in any case, let's get the power supply back to 5 volts. I think that's everything I intended to show with this video. I didn't really prepare much. It's just kind of a quick thing I wanted to test right now. But when you're learning about components, obviously I try to come up with circuits where you can see the component doing something interesting. And obviously at some point, if you're building circuits, you want to do something interesting. But ultimately, building circuits depends on you understanding the component in as much detail as possible. Might as well turn the meter off now. And you know, test out the component. Just measuring like the voltages across it and stuff, or however much current it lets through. Whatever kind of testing you like to do. But especially like if you read like the gate voltage here. If you're reading about the gate voltages, actually take the measurements. And you know, once you take actual measurements, then you understand the text that you're reading that's explaining the gate voltages and stuff. In this case, much better. When it comes to reading data sheets, they mention all kinds of different voltages in relationship to the different pins right there. And it doesn't make any sense at all until you get a little experience measuring them. At least they didn't for me. So in any case, that's it. I hope you enjoyed the video. It's kind of a bonus video. Just a random topic I kind of came up with. But it is related to the component I've been using in a number of videos recently. So hope you enjoyed. Make sure you check out one of the other videos I'm posting on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.